going to go ahead and take a look at the 7.2 lesson. In 7.2, we're starting to be able to look at an equation and decide whether the given value is a solution of the equation, and we're also going to start solving equations using inverse operations. There is a lot of new vocabulary in 7.2, so that's the first thing we're going to look at. Over here for key vocabulary, a solution is an answer. And inverse operations mean opposite operations. So the inverse of addition would be subtraction, and the inverse of multiplication would be division. Equations may be true for some values and false for others. Values are numbers. A solution of an equation is a value that makes the equation true. In the chart at the top, there's a value of 3, 4, and 5 for x. Then they're taking those values and plugging them into an equation and deciding if both sides are equal. One important thing to notice is how these are written. We're building fundamentals of algebra in just writing these out correctly. So, in the first one, it says the value of x is 3. That means that x equals 3. They're putting that 3 into the equation where x was. They're plugging that in. And then they're checking to see if that's true. One important thing is that all of these equal signs are lined up. In that section, we actually see 3 different types of equal signs. We see a traditional equal sign, which means equal. We see an equal sign with a question mark on top, which is asking the question, does it equal? And then we see an equal sign with a line through it, which is saying does not equal. So in the first one, we can read this as x plus 3 equals 7. We put 3 in for x, and it says 3 plus 3, does that equal 7? Then we simplify over here. 3 plus 3 is 6. 6 does not equal 7, so they have an x. Are both sides equal? No, they are not. So we know that the value of 3 is not a solution or an answer to this given equation. Example 1, checking solutions. Tell whether the given value is a solution of the equation. As we were talking about in 7.1, directions are extremely important. Tell means I need to actually write a sentence or write words with my answer. Whether the given value, so the given number, is a solution, is an answer of the equation. In 7.1, we learned that equations have equal signs. In class, we wrote some steps out here on the left-hand side that I'll model for you in example A. So number 1, the first thing we're going to need to do is rewrite the equation that is given to us. If we look at how A is written, we see that it says p plus 10 equals 38, and then there's a semicolon, and p equals 18. That semicolon is separating the equation on this side from the given value, or the number that they're giving us for the variable p, so that it's showing that these two things need to be used together, but this is not one run-on math sentence where we want students to be thinking the 38 and the p go together. So that semicolon separates it for you, so we see, okay, here's the equation, and here's the given value. So step 1 in algebra, and you will write algebra this way all the way through high school, so it's important to start learning how to do this correctly. I'm going to rewrite p plus 10 equals 38. Once I rewrite, my step 2 is I need to plug in the given value. So it told me p equals 18. So where I see p, I'm going to write down the number 18. As I mentioned up at the top of the page, our equal signs should be lined up in algebra. So I'm actually going to do my equal sign first so that I make sure everything is nice and lined up. 18 goes in where P is, plus 10, and I'm asking, does that equal, so I put a question mark there, 38. My step 3 is to simplify. That again is coming from 7.1. Simplifying means I'm putting together things that are alike or things that are the same. So I can add 18 plus 10 to get 28. So does this side equal that side? Does 28 equal 38? No. So I'll cross that out. And then I would write no, 18 is not a solution. In actually it was back in chapter 3, we learned about 4 or 5 properties of multiplication and addition. We learned the commutative property, the associative property, distributive property, identity property, and zero property. Now we're getting to properties of equality. So, the addition property of equality says that when you add the same number to each side of an equation, the two sides remain equal. It's giving us an example that if I add 5 to both of these 8s, I still end up with 13. And then it's showing us in algebra, if I had a minus 4, and I added 4 to both sides, just like we did over here, x equals 9 is equal to x minus 4 equals 5. It just looks different. But they're equal because I did the same thing to both sides. Same thing down here with subtraction. I can subtract the same thing from both sides, and it will still be equal. Over here, if I had an addition I wanted to get rid of, I would subtract from both sides, and I would have an algebraic answer that was equal to the equation that I started with. This right here, where I go from subtraction to addition, or addition to subtraction, is inverse operations, like we talked about on the first page. Alright, example 2 has us solving equations using addition. Solving means we need to get an answer. So we want to end with the variable equals and then one number. So both of these are using x. So we want to have x equals and then whatever number x equals. Notice that our directions this time say solve. In 7.1 we were writing, not solving. So we need to pay careful attention to the directions. From our steps from the previous page, we know the first thing we need to do is rewrite. X minus 2 equals 6. My goal in algebra is always to get the variable by itself. That looks like what we're talking about right here. X equals something. Y equals something. The variable is by itself on one side of the equation. My rule, the way that I'm allowed to do that, is that whatever you do to one side, you must do to the other. And that goes back up to these properties of equality. So again, my goal, I want x to be by itself. So down here later, I want it to say x equals and then have a number. That's my goal. If I want that to happen, I need to get rid of minus 2 on this side. So my rule is that whatever I do to this side to get rid of that minus 2, I'm also going to do to this side to get rid of my minus 2. Just like in the examples above, if I want to get rid of a minus 2, I'll use the inverse operation and I will add 2. Remembering my rule, whatever I do to one side, I have to do to the other. I can draw a line to show that I'm adding those up. My minus 2 and my plus 2 go away. They cancel out. All I'm left with is x. I make sure my equal signs line up like we did in example 1, 6 plus 2 is 8. I can go back in and check my work with this as well, like we did in example 1. Is x equals 8 a solution of this equation? So x minus 2 equals 6. Rewrite. So I'll plug in 8. 8 minus 2. Does it equal 6? 8 minus 2 is 6. So yes, it's a solution. That's a great way for students to know whether they're getting these correct or not. Example 3, again we're solving equations. This time we're using subtraction. Step 1 is to rewrite. I think of my goal. I want x to be by itself. I think of inverse operations. I want to get rid of a plus 2 on this side so that x can be by itself. That means I'll do minus 2. My rule is whatever I do to one side, I have to come over and do to the other. A plus and a minus, those inverse operations, always cancel out. X equals 9 minus 2 is 7. I'm going to check that solution, rewrite, plug in. Does it equal 9? 7 plus 2 is 9. Yes. This is really what they're receiving credit for in solving. But this is checking the work to make sure that we're getting full credit. We're making sure we didn't make any silly mistakes. Example 4 is a real-life application problem. Remember that those are going to be the type of problems that show up on tests. They really pulled together all of the skills from examples 1, 2, and 3. So example 4 says your parents give you $20 to help buy the new pair of shoes that are shown. After you buy the shoes, you have $5.50 left. Write and solve, so that's 7.1 and here's 7.2, an equation, which means equals, to find how much money you had before, I'll use the variable b, your parents gave you $20. Anytime it says shown, it means they're giving us valuable information. This price tag over here is really difficult to read. We're going to assume that's $59.95. When I'm writing my equation, I'm taking the money I had before, b, adding the $20 the parents gave, and that total amount equals the cost of the shoes, $59.95, plus how much money was left over. Now I need to start simplifying first. When I simplify, I'm combining things that are the same. When I'm writing algebra, I want my equal signs to be lined up. I need to do $59.95 plus $5.50. When I'm adding decimals, my decimal points need to be lined up. 5 plus 0 is 5. 9 plus 5 is 14. Put the 4 down, carry the 1. 9 plus 1 is 10, plus 5 is 15. 1 plus 5 is 6. My decimal point comes straight down. So this side of my equation is 65/45. I'm going to copy down b plus 20. That was simplifying. Now I'm going to solve. When I solve, I remember that my goal is to eventually down here have b equals something. I need b to be by itself, so I need to get rid of a plus 20, which means I'll use the inverse operation minus, and whatever I do to one side, I have to do to both. I need to be careful that I line up my decimal points. The decimal on a 20 would be there. My plus 20 and my minus 20 cancel out, and I'm left with b. I make sure my equal sign lines up. Over here, 5 minus 0 is 5. 4 minus 0 is 4. 5 minus 0 is 5. 6 minus 2 is 4. And I drop my decimal point straight down. That means that b equals 45/45. I'm going to write this out in a sentence, and I'm going to look back to see what sentence I should write. I need to find out how much money you had before your parents gave you $20. So I would say I had, with a dollar sign, 45/45 before my parents gave me $20. Thank you for watching this 7.2 lesson. If you are a student looking for extra credit, the secret code word for 7.2 lesson is turkey. Thank you, and if you have any questions, please feel free to email me.